Good morning, everyone, or good evening, or good day, or good whenever it is. Welcome to IETF112. The time is 12 o'clock UTC, so I think we're probably going to start. No, we are going to start. There's no probability about it. I hope you can hear me. Can somebody say yes if you can? Yeah, thank you, Ed. So I'm Rick, who's speaking. Ed is the other person who's currently streaming video. We are your chairs, and this is the DTN working group meeting at IETF 112. So just to go through some administrivia to start with, this session is being recorded. By opening your mic or turning on your camera, you are agreeing that anything you say or wave will be recorded and is in the public domain and will be displayed on YouTube in the future. So for reference on that, there is the, I'll come to that on the note well in a second. So our agenda is at this URL, but I will present it as well. There is a participant guide for using Meet Echo. I know we are all mostly familiar with this, but there may be some new attendees who aren't. If you follow that URL, there is a good explanation on how to use Meet Echo. Obviously, this is a bit of a catch-22. If you are listening or hearing me now, that implies you have managed to get into Meet Echo in some way. There's also a way to report technical issues if you have any. So this is the standard IETF note. Well, this covers the code of conduct, the rules and behaviors, the basic background to the IETF processes, how the IETF works, how the working group works, how one is expected to behave, what happens if you have difficulty with the behavior of other people or you behave in a manner that is not seen as the way the IETF wishes to hold their proceedings. There is also important information in BCP 78 and BCP 79 concerning IPR, copyright, patents, and how you participate in the IETF. If you have not read these recently, I do recommend you read them, including the privacy policy. Here's a short summary. The chairs can help if you have questions, and we can forward your questions to members of the Ombuds team if we are unable to help or you feel that we can't. So the agenda for today's meeting. We are currently covering the 10-minute discussion from the chairs about admin. We will then have a 20-minute discussion about the charter, because as some of you are probably aware, the working group is completing its current charter and there has been much discussion about rechartering. I know at the last IETF meeting we discussed proposed text. The working group came up with some proposed text. Since then, the chairs, RADs ahead, and the IESG have been wrangling over various use of various terminology, what the ISG would like to see as compared to what the working group would like to see, and we've got a report from the chairs on how that progressed. Some of you may have read some of that on the mailing list, but there hasn't been much discussion, and this is a good point for us to give you a summary. Then we will have a couple of presentations about some of the BPv7 type stuff, Wireshark dissector from Brian, an update from Brian on the COSI security context work. Scott Burley then has an interesting presentation about scaling DTN out to bigger networks. I'll have a comment about that before he actually starts, but having had a sneak preview of his slides, I think that's interesting. He's got a 25-minute slot because he covers a lot of subjects. We then have asynchronous management architecture update from Emery, which will be relevant particularly in light of the charter updates and the proposed new charter. And then Sarah has a shortish presentation. I'm afraid she's been a bit squeezed for time, talking about network management in challenged environments and some tooling around that. We also have a 10-minute section for any other business and open mic. So I think we would prefer to have discussion about individual topics squeezed in at the end of each presentation, but if there's general discussion that isn't covered by any of the presentations, that 10-minute slot is the perfect time for that. So a couple of bits of administrivia. The Meet ecosystem can struggle. This is not so true anymore. It's got really good, in my opinion, but of course, if we have lots of participants, then obviously in the world of streaming video, things can get a bit laggy, particularly if you have a long latency link. Please be patient when turning on your mic and before speaking, because there is a round trip time. It's not on a delay tolerant scale, but it still can be tens to hundreds of milliseconds, so just be patient. But in this COVID era, I think we're all a lot more experienced with video conferencing systems. More importantly is the minute taking. So CodeMD is the interactive multi-person markdown-based editing system that is built into Meet Echo. I believe the relevant button is on the toolbar on the top right of Meet Echo. Please help contribute to the note-taking. I know Adam, our secretary, is intending to take notes as fast as he can. Please help him out if he mistypes somebody's name or mistypes your point. It's worth just double checking, particularly if you ask a question or respond to a question that's been captured correctly, and also just help out. We're trying to be collaborative about this. Also, important information, so the mailing list. Dtn@IETF.org is where the main procedures of the IETF are actually handled. So that is the canonical reference for decision making and the really good place for discussion on subjects that the working group are working on. If you wish to contact the chairs, please use the dtn-chairs@ietf.org, and that will get to Ed and myself, and it also gets to the AD. So if you've got administration questions, queries about working group process topics, that's a good place. If it's about technicalities, the DTN mailing list is the right place to go. We're the chairs, not the de facto experts in this field. So very quickly, document status. So many of you are probably aware that there have been the big 4 documents that we have been desperately waiting to complete as part of the current charter cycle. They being Bundle Protocol version 7, BPSec, a default security context for BPSec, and the TCP-based convergence layer, which is TCP-CL version 4. Good news, they are all at the RFC editor state. That means the RFC editorial team is actively working on the documents to make sure the language is accessible particularly for non-native speakers. This is an important part of the RFC editorial team's objective, and also to make sure the documents are internally consistent and do all the good work that an editor does. And they're a good team. So they expect to have completed that work in the next 2 weeks, according to the correspondence the chairs have had with them, which is fantastic news. At that point, the documents will reach what's called Auth48 state. Auth48, for those who don't know, is the 48 hours the authors have to respond to the edits that the editor has made to say, yes, I approve, no, I don't approve. Although it's called Auth48 state, sometimes it can drag on a little bit, particularly when authors aren't paying attention because they were involved at the beginning and not at the end of a document, etc. The good news is all the authors whose names are on those 4 documents have all already responded to the chairs to say, yes, I'm here, the email address is valid, and I am very happy I am prepared for the Auth48 state and to reply promptly to the RFC editor, which means, with luck, we should have 4 RFCs before the end of the year. That's what we're really hoping. And if that comes to pass, that would be a fantastic end of year for the working group and would nicely close off this charter cycle with 4 RFCs. And I think we should all be very pleased to see that happen. So I'm going to hand over to Ed now to talk about the working group charter in some detail. Well, I'll cover some of the later parts, but Ed, do take over and shout next when you want me to change the slides.
Can you hear me now? How about now?
Yes, we can. I turned my audio off.
Someone keeps muting me, so I think you can hear me now. Okay, So yes, now that we have that hope of getting 4 RFCs through by the end of the year, the next obvious question is what next? We've talked about that significantly, both in the mailing list and at prior DTN working group meetings. And we did propose an initial charter. And that initial charter, when it went through IESG review, came back with some excellent comments, and then 2 comments that were blocking. I think it's important. All of the authors of the 4 RFCs that are coming out of the editor in the next few weeks understand what it's like to go through last call reviews and IESG reviews and the nature of blocking comments. And they are typically not, you are doing something incorrect. They are typically, have you thought about this? Or will you be sure to review things with us? And that was the nature of the blocks that we saw for this, for our proposed charter work. And the 2 blocks that came from different areas were from the ops area related to network management, and from the routing area related to anything associated with routing work. And even though when we walk through our charter in a few slides, we make specific statements about what we want and don't want to do relative to routing, we want to make sure that we are always working with the appropriate areas and working groups. The important part of this is that Rick and I have negotiated this from a charter perspective. We have not significantly changed the work that we want to accomplish in this charter, but we have been able to explain how the work is focused on challenge networks. The blocks have been removed, the charter text has been updated, and this will go into the telechat for December 12th. And we are certainly hopeful and expect that the charter would then be approved. And we are proceeding as if this will be our charter, unless Zahed says something different.
No, I turned on my audio and video just to confirm that yes, that has been the case. And this is now from yesterday on the external review. So that's the next phase. And then we'll see how the IETF approves or not. We might get some comments in the external review that we need to handle it. But yeah, we'll see when it.
And by the way, all of the comments that we received, blocking or not, were very good comments, and we did incorporate and respond to all of them. We didn't turn away any of them or say that we disagreed with any of them, and that has been the nature of the review of IETF in general. The technical review that we've gotten through all of this work is just terrific, and we are appreciative of it.
So this is perhaps the right time to say, I mean, from IIG, my colleagues, other ADs, and they have been super impressed by the work that have been produced by the DTN working group. So congratulations and thanks for doing the really good work. I hope to continue this work in a same spirit. And obviously we have some challenges, like, I mean, we're sitting in a TAPS transport area, and we have lots of things to do on the ops and other areas, but we are very used to this environment, right? So that's not a surprise for us. So let's continue doing the good work, and hopefully the recharter will complete by the December 12th telechat.
Absolutely. So Rick, if we go to the next slide, if we were to take a step back and look at the kind of blocking statements that were on that charter, they really came down to a common concern. And that is that DTN, delay and disruption tolerant networking, touches lots of topics, and not just topics that are restricted in an IETF sense to the transport area, to the transport area. And so when the working group starts to address these other topics, like network management and like routing, it's starting to look at other IETF areas as well. And an observation that we have made time and time again within the DTN working group is that, yes, while network management, ops in general, is a different area within the IETF, and while routing is a different area within the IETF, we are driven by the fundamental challenges of our transport layer and the challenges of our network environment in which we have to exist. And therefore, some of the things that we need to do in security, in network management, and routing, and so on, will also be driven by a deep understanding of our transport, which is a little bit different than the transport that others have for the bulk of the work in these other working groups. And so, for that reason, we do think that the work is still reasonable to perform right here, because this is the community that understands the challenged environments in which we would be operating. However, we do need to be much more involved with soliciting good inputs, technical review, and staying in touch with and synchronized with all of the work that is going on in the other area in the other areas. So at the end of the charter, we sort of address this overarching concern by saying that we will coordinate with other IETF working groups. Particularly, we call out security, routing, operation, and management areas, and we make sure that we're going to get early peer review while we are developing all of our work, as opposed to waiting until last calls or waiting until a higher level, IETF-wide reviews, when at that point a lot of the day-to-day technical back and forth has already been done. And I think that just simply making sure that we understand that and we communicate that to the other areas has gone a long way in making sure that everyone understands that we are trying to both satisfy the unique portions of the environments in which we operate while recognizing the work that's going on by others. So Rick, if we then go to the next slide, we have a couple slides on what that means specifically for operations and management, and then a couple of slides associated with what that means for routing. So we in the Dtn working group adopted something called the asynchronous management architecture. It spent a little bit of time looking at prior work associated with SNMP and NetConf and the network assumptions associated with that, proposed some autonomy models and also some additional ways in which a DTN would like to manage sort of a local autonomy and how all of that would work in a very challenged and disrupted environment. When that document adopted by the working group and went into larger last call, the ops area came back and they felt that that AMA did not really address recent work in NetMod and in other areas to talk about asynchronous management. And asynchronous management could be RESTconf, asynchronous management could be Yang push, asynchronous management could be some of the additional things coming out of Yang 1.1. Simply titling something asynchronous does not mean appropriate for DTN or autonomous or able to operate in a challenged environment. So simply titling our architecture an asynchronous management architecture is not really focusing on the unique needs of a challenged environment. And certainly the operations area asked for clarification on what we meant when we said asynchronous management. So to that end, we have decided we absolutely need to clarify that. And so the AMA document will be reissued to be called something like the Delay Tolerant Network Management Architecture or Challenge Network Management Architecture or something similar, so that we understand it's not just asynchronous. You can have asynchronous that doesn't solve DTN problems, for example. We're going to make sure that as we update that architecture, we will analyze the existing asynchronous work that's coming out of the other operations area, and to make sure that we express the needs of a challenged environment in particular to ground it into the unique characteristics of our transport. And then we're going to use this document as well as both a chance to synchronize with the other areas and to do a gap analysis of those existing IETF management protocols against the needs of DTN. My expectation is that there are some architectural elements here that we will add as we learn the work of some of the other areas. And there are some things that are probably not going to change much because they are well-tuned and well thought out for the environments in which we operate. But that's the work of the working group to figure out. As we get through that, we're going to then go through another round of technical review and last call, again, reaching out to the NetMod community and the ops area in general. And this will be the first of many interactions where we get that cross-area review of the work that we are doing. Rick, next slide. And then so then the last part is just, well, what about the rest of the work? We have, in addition to the AMA, we have application data models, we have asynchronous management protocol and the CBOR encodings thereof. So once we have the architecture complete, once we have that gap analysis complete, once we have incorporated and reviewed what that looks like otherwise, then we will go back and look at what does the transport of management information between devices look like, what are the efficient encodings, and do we already have those efficient encodings by adopting some of the existing standards? How do we express the need for deterministic autonomous operations? We do have some ideas as to how all of that will fit in. And sort of the last thing that I wanted to make sure becomes very clear, particularly for the folks who've been working on what we've termed the asynchronous management architecture for really a few years now, none of this stops the fundamental work or the problem that we're trying to solve, which is simply that managing things across a highly delayed or highly disrupted network is a difficult problem that is not well solved yet. And we do have unique aspects to this. We may reorganize some of these documents. I personally would like to rename some of them because I don't think asynchronous fully covers the needs of a challenged environment. But once we get through all of that, the actual technical work that's being done and the problem being solved isn't changing really all that much at all. And so as we work through this, what's going to happen is we're going to get a lot of very good technical review, and we will appreciate it. And at the end of that, I think we're going to have a much better technical solution that integrates much better with tooling across the IETF, and frankly becomes an awful lot easier to talk to with other network management experts, because then they can start seeing in terminology and in architecture and structure things that make sense for how terrestrial management is done, or more terrestrial management is done. So those are our thoughts on the management side. And then Rick, why don't you take it over for routing?
I'll turn my mic on. The other block really came from the routing ADs, who had a concern that very similar to the concern that the ops area had, or several of the other areas had, which was the routing area has the experts in routing and many years of expertise in solving and understanding the multiple different problems that exist within routing. And although there was a good understanding that DTNs have subtly different challenges when it comes to routing, they really do want to be involved in routing. So as we discussed at IETF, at the last IETF, routing is explicitly out of scope for the next charter, for the new charter, I'll call it. And the reason for that is pretty simple. We have to be pragmatic and set ourselves achievable goals. Without a naming and addressing framework, a concept for forwarding and neighbor discovery and all the building blocks that are required for routing, we shouldn't go standardizing routing protocols. Because we will have to immediately update them or discover that the scaffolding on which they stand is completely incorrect or incomplete. I think it's ill-advised, and the consensus of the working group as of the last IETF was, yes, we will not tackle routing. However, the chairs did feel that there was it was worth having a line in the charter to explicitly say that, because routing is such an attractive thing to look at. Routing in DTNs is a great subject and is required. People do understand that we need it. We felt it was relevant to have a section in the charter to say routing is out of scope. That does not mean that people can't discuss routing. And routing should definitely be a great subject for side meetings, for discussion, etc. But we will not be adopting working group documents that are concerned with routing. So even though we had that line in there, the routing ADs worried that that would imply that the working group was going to do routing at some point and was going to do routing in isolation. So we have added extra text to make sure that alongside the statement about routing is out of scope, but also to say that when routing does fall into scope, it will be done hand in hand with the routing area. Now, this may be the case that in 2 or 3 years' time, when we come to recharter, that we actually say, well, perhaps there should be a DTN routing group as part of the routing area. Perhaps there should be a space-based routing group, because I know there's a lot of interest about LEO satellite swarms. Perhaps, you know, a working group which looks at space routing problems that exists within the routing area might be a good idea. This is the future, but what we did want to state was we are not ignoring routing when we discuss routing. It's really that simple. And by explaining that and making that clear in the charter, the routing AD was absolutely fine to lift his block. The other comment made by the routing AD was the MANE working group, which is the Mobile Ad Hoc Networking Working Group, which many of you are very familiar with, which lives inside the routing area. They have a working group charter item called covering management for mobile ad hoc networks. Now, they have currently not got good working group documents on management, and also have looked at what this working group is proposing in terms of AMA. which we should no longer call asynchronous management, but looking at some of the approaches we're taking for challenged environment management, particularly for DTNs. And they are very interested in what will read across to the MANE challenges from the DTN challenges, and whether actually they could lean heavily on the work that's happening in this group, perhaps extending or collaborating to make sure that work has applicability in MANE or not. So to that end, we have also specified that we will liaise with the MANE working group as we work on some of the management issues. And Ed is presenting in the MANE working group session 3 today, so that's 3.5 hours from now. And I also happen to know a number of the participants in DTN also participate in MANE, because there's obvious crossover between the two areas. So by covering those 2 points, we managed to lift the block. We satisfied Alvaro, the routing area AD, who performed the review and said, hold on, I've got issues. We satisfied him and we can move forwards. What's last? So the final piece, and this is really feedback from our own ADs ahead, which is at the end of the charter, we propose some milestones, and these are the same milestones we discussed at the last IETF meeting. Really, we need to, when the charter is approved, we need to insert these milestones into the data tracker to say, this is what we're working on. And associated with every milestone is a date. When do we think we will have each of these documents ready for working group adoption? We can then try and predict whether they'll be ready for, when they'll be ready for IESG review, but I understand that is quite a big guesstimate. But we do need to associate dates with these milestones so that Ed and I as chairs can get these correctly put into the data tracker. This is it's always difficult to estimate how long it will take to come up with documents, and particularly when the content is bleeding edge. However, there is validity in having these dates because it gives guidance to external SDOs and other organizations who are watching the progress of this working group, and it gives them some idea of what we believe we will achieve, the timescales in which we will achieve those. So although it sounds a little bit like we're making work for ourselves by trying to guess when we're going to do these things, the benefit of having even a guess of a date, we would like to achieve by date, is better than having no date at all. So to that end, when people present on some of these subjects, and I don't actually think anyone is presenting on any of these subjects, sorry, I'll take that back. There are authors who have personal drafts which cover some of these documents, some of these topics, and I know there are people who have stepped to the mic in previous IETFs to say, I am really interested in working on this. I am really looking to those people to provide information on the mailing list to say, yes, I want to do it, or yes, I am doing it, and I think I can have this document ready for working group adoption, i.e. their personal thoughts are down and concrete, and now we're ready for the working group to decide whether to work on it. If we can get a good estimate of when those dates are in, we can get the milestones in place, and that has benefits, as I've said before. So the chairs will be taking an action to send an email on the list to all the authors of all the current specifications that are personal drafts saying, can you guesstimate a date, please? And then we can get that working. If someone wants to take anything to the mic and state a date here and now, that would be great. It saves a round trip of an email, but we do need those dates. That's it on the charter. So just opening the line to questions, etc. I'm quickly jumping back to Meet Echo so I can see if anyone's got any comments in the chat. Does anyone have any comments? So Abdul Salam has joined the queue. If you raised a question in the chat and you want to take it to the mic, please feel free. Go ahead, Abdul Salam. I think you were first, or was it Zahed first?
Yes, Abdul Salam. Yeah. Okay.
I'll intervene a bit.
Okay.
So before, I think Rick and Ed has given a very good summary of what happened, and I think we're all now all our like how things are working now. The thing that I just want to mention, and I mentioned in one of my emails, saying getting advisors from other areas is not out of equation, so to say. So we can still work on. It's very hard to get somebody to commit to come, but we can try to get something. I personally believe like having an advisor from other areas would be very nice, but as perhaps we all know, it's very hard to find someone. So if you have contacts and you know somebody that who can help us, maybe that information you can also provide here or in the mailing list or to the charter or to me so that we can reach out to them. That's all.
Thanks, Ahad. Go ahead, Abdusalam.
Thank you very much for the presentation. Regarding using or including routing in this working group, I actually agree that it's better to do the routing in routing area. But in the same time, let's say for this working group, if we look at our documents after it's published or it's RFC, if the routing is depending on our documents and our working group, it's like there are some from before documents are dependent. One document is depending on other document. So if it's an independent document, yeah, it goes for the routing working groups as managed and so on. But let's say if we have our DTN document, which is RFC, and it's very important that some routing protocols is depending on it, maybe I think the AD may give us option that we do it in our working group, or we can join with another working group. Yeah. So this is like there is some kind of reason why we use it. We need this routing in this area, in this working group area.
Okay. Completely understood. Really, that is a discussion that will happen after the next charter cycle. So yes, very valid point. I can think of some counter arguments, but that should be left for, I think we've got 2 years before we have to have that argument. Hopefully by then we will have thousands of working group participants, and having multiple working groups becomes a logical organizational step. If we, let's talk about that in 3 years, but thank you, Abdusalam, that is a valid point. Go ahead, James.
Speaking to your question about, when do we hope to have some of these new drafts or documents in, I'm going to be speaking to y'all later about the asynchronous management architecture or whatever we want to call it. My goal would be to try and get something forward by the next IETF113. So and I think that sets the pace for getting some of these other documents for administrations and management that we really need. So
thank you. Because the AMA is a really critical one in terms of timeline. So that's really pleasing to hear. Thank you. That's actually a working group document anyway, but that's great. We can have a solid milestone for that. Thank you. Sorry, I don't know what the J stands for, but go ahead. Ignacio? You're on mute, I'm afraid.
I didn't find the correct thing. Well, this is my first time in this working group, but I am usually working in routing protocol. This is why I'm doing some question on the chat. But okay, little surprise about your talk about that. But no, my main concern is because some working groups like Manet or Babel, for instance, they are very, very concentrated in a special situation of routing problems. And DTN has another things. This is just that. And for instance, quality of service, if you decouple it from routing, it could be really very, very tricky. I understand that there are a lot of things to do besides routing, and this is why you are trying to tackle this part firstly. But well, just to express this point of view.
Well, I completely agree. It would be great to get onto routing, and maybe we should use that as a an inspiration to tackle all the topics we need to do first as quickly as possible so we can get on to the exciting thing about routing. And let's not get sidetracked into a discussion about where the routing work happens. That's really up to the IESG. I think we have people who are interested in doing it, no matter what the working group name is called and no matter how it's organized within the IETF. That's actually less important than working on the cool technology and coming up with standards that really work. So thank you.
Thank you.
I think that's the end of that, and we're about 5 minutes over, which is terrible when the chair's overrun. So next up, I can't see the agenda anymore because I'm showing slides. Who have we got first? I think we have Brian Sipos with administrative record types. Brian, are you ready to present? Do you want to present your slides, or do you want me to present them and you shout next?
I'll share the slides.
Great, thank you. Then that's a bit easier for me. I'll stop sharing.
Do the mechanism here. I think I need to be approved.
Oh yes, I need to click the green button. How's that?
And I will find it.
I'll turn my video off so nobody needs to watch me anymore.
Okay. So this is going to be a short presentation. And what this is about is that as part of some other related work in the ACME working group, there's a need to define a new administrative record type. And if you look in the IANA registry for bundle administrative record types, they exist, but only for BPv6. And there were a bunch of tables that as part of BPBIS, they were expanded upon to include a column to indicate a bundle protocol version, the block types registry and flags registry and some others. But this wasn't done with the administrative record types registry, sub-registry. And so what this document is proposing is to just do the same for this other code point registry. And it makes a couple of other changes that I'll talk about in the next slide, but it makes an explicit reservation, and it also makes an experimental range reservation too. And the experimental range isn't necessarily driven by anything other than they're the large values that correspond also with the experimental reservation that was made in BPv7 for the other registries. There's no change made to the registration procedure here. It's purely about just marking this as BPv7. And the reason why this wasn't treated as a blocking issue for BPBIS, BPv7, is that the document as it stands is self-contained and consistent, and there's not a problem with it. It just has an explicit table of these are the administrative record types, and that's it. So an agent isn't told that it really should use an IANA registry instead of an explicit table. So on this slide is what the changes are from this small document. And this really is the meat of the document, is to make these changes to the IANA subregistries. The bundle protocol version column in the left is what's new. And you can see that the reservation of code point 0 and the status report are already part of BPv7. This is just adding them to the IANA registry. The code points 3 to 15 are still unassigned. And then that second table is really what's new. And in BPv6, only values up to 15 are encodable. In v7 now, we have a whole CBOR integer range, which is 64-bit. But what this registry does is just say that the 16-bit range is assignable, and everything above 16 bits, which would be 4-byte encoding, is reserved. Currently, I'm requesting for the working group to adopt the document. And the reason for this is that as of yesterday in the ACME working group discussion of the node ID validation, They are interested in progressing that document into the editor queue before the end of the year. So my request is for this to be looked at as possibly being put into IESG review in a similar time frame. They would end up being in a review cluster together because they're dependent on each other. Well, the Acme document is dependent on this one.
Okay, thanks, Brian. My first question was, are you asking for working group adoption? But you've answered that. I think that seems perfectly reasonable to me. So we'll do a call on the mailing list for working group adoption. I thoroughly recommend people have a quick read of this. This sounds like one of those kind of scaffolding documents that needs to exist. So I'm really hoping it's short and understandable. The working group can have a quick glance at it. We can get it adopted. And I share your desire to move quite fast on this. Given its updating registries, it should be short, sweet, and non-contentious. So I hope that the working group shares my desire to move this fast, and we'll see what we can do.
Yeah,
okay.
The good news is that there's only actually one requirement in there, and the only thing and the only thing that is really variable is what is the experimental range. And I don't have any strong feelings on this. This is consistent with some of the other BPv7 reservations.
Yeah. Okay, thanks, Brian. I don't think anyone's in the queue to contend this. So do you want to go straight on to your next presentation, which will buy you a little bit more time?
Yes. Yep, that sounds fine. And which one was in the agenda?
Which one did we have next? I've lost the agenda again. I should just too many windows open. I think the next one is Wireshark dissector. Yeah.
Okay. That should also be short and a bit quicker than
pop-up windows. There you
go. So the point of this presentation is just a little informational and a little public service announcement about some work that was started under the TCP/CL updates as proof of concept and as diagnostic tool, but since then has recently transitioned to the upstream project. So this started out as a TCP/CL, expanded to BPv7 more generally, and later on in 2019 to BPsec. And there is still a repository for doing some of these more prototyping things like the Acme node ID validation and the COSI context. But the main dissectors for updates to TCP/CL for BPv7 and BPsec made it into the Wireshark main branch last month or a couple months ago. They've been sitting in a queue for a while. New protocols get a little more rigor in their review, but they finally got approved, and so this is good news. The way that this was done is there still is a generic bundled dissector, which in the past was for versions 4 to 6, and there's the version introspection that was added so that dissector can detect v7 with the CBOR encoding and do its own separate dissection. So the bundled dissectors are separate, but there's introspection to be able to do the same kind of thing that was happening already for IPv4 versus v6 and other version introspection kind of work. And one of the good things about the architecture of how this is done is that Wireshark has these things called dissector tables that let you delegate across protocols. So this is layering and making protocols cohesive but extendable in the dissectors. So all these things listed here are dissector tables, meaning that you can experiment with plugins to add new TCP/CL extension types, to add new block types, add new admin record types. The point of this is to make experimentation easier. And the dissectors for TCP/CL and the bundle include defragmentation logic that's built into Wireshark. They include sequence analysis, timing, and things like that, hopefully to make it easier to troubleshoot these things. The one change that was lost from the original TCP/CL was the ability to opportunistically dissect messages if you don't have the contact header, because that is, the contact header is where the version is indicated. And without the contact header, the rest of the TCP stream you can get segments of, but there's no explicit version indication. And so that is, I'm going to skip to the next slide. That is something that could be potentially added in the future if there's enough interest in doing it. We'd have to come up with some logic for how do you do what's the word, heuristic dissection of, does this look like a BP TCP/CL v4 header? Does it look like a v3 header, and so on? But I have a couple of examples and screenshots here, and these examples come straight out of unit test files that are included in the upstream source now, and they're really just basic proof of work that the thing is doing the right job. But you can see here in the TCP/CL dissection that you can see the different messages being dissected in the different TCP segments. You see in the bottom that there's some sequence analysis of telling you that this acknowledgement message is acknowledging the segment that's in frame number 12, and it took 4 milliseconds to receive this acknowledgement. And so you can get some information about the performance of the underlying network here, and hopefully help with troubleshooting if things are working as you would not expect on a real network. And then on the next slide, the BPv7 focus of the bundle framing, all the different blocks and block types. There's some very basic sequence analysis, such as it extracts the bundle identity, which is the source EID and the time and the sequence number. And then there's some simple logic about retransmits, and this is all in the form of how Wireshark already deals with all of this stuff to begin with. So, you know, retransmits are not something new for bundle protocol. So there's a bunch of ecosystem of UI that already exists for dealing with these things, and we're trying to squeeze this into that form. But you can see that each of those canonical blocks of the different types use different sub-dissectors in those dissector tables. So adding new experimental block types to a local plugin outside of the Wireshark source. So you don't need to rebuild all of Wireshark to exercise a plugin. Is pretty straightforward. And then as far as how this is going to continue on in the future, the base dissector without some bug fixes and enhancements that were made afterwards is already in the 3.6 release branch. So that should be present by the 3.6 release. The TCP/CL dissector, some enhancements to the BPv7 are likely to be in the 3.8 release, but that branch hasn't been created yet. But this is just a rough idea of when to look for these things. And a couple of notes, the version introspection logic right now is a little bit ad hoc. It's not really based on any documented standard. Just to mention that there's some similar logic that was written up in a personal draft. If there's any value in having a standard way of doing this introspection of which version do you try first, look for first, which one takes precedence, what is a failure mode, this could be extracted if there's any desire to do so. Like I was saying earlier, the TCP/CL opportunistic message dissection could be added. It's a similar sort of thing of just adding some logic of looking at what might be a message header and saying, does this look close enough to a v3 header? Does it look close enough to a v4 header? And the last point I want to make is that now that the main dissectors are in the upstream project, that it's up to the Wireshark project and the community around it to manage these things. So Wireshark has a public issue tracker to identify defects and enhancements. The normal merge process is all there. And as of a recent review, I actually did find an issue with the BPSec dissector in some circumstances and wrote up an issue about that.
Thanks, Brian. That's great. I'm in the queue, so a little personal comment. Actually, no, chair comment. If you wanted to write up an opportunistic message dissection draft, I think it would make a great informational document. I mean, I suppose it's not standardizing anything outside the scope of the UDPCL stuff, but a little informational document which says if you get some random fragments of a TCP/CL conversation in order to determine the version, then you might want to follow the following logical steps. I mean, if you want to write it up, that's the kind of thing that is in the next charter as a kind of operational experience thing, and informational would be the right way to go if you want to do the work. Otherwise, this is great. It's I kind of, from a personal opinion, having your protocol in Wireshark mainline kind of means you're now a grown-up proper protocol, because Wireshark understands you. So, which is credit to the Wireshark team for their penetration of their tool. But yeah, this is really cool. Thank you.
Okay, and that was my time. Oh, more in the queue. You can go ahead, Zahed, if you want.
Sorry, I muted myself before saying go ahead, Zahed.
So this is very good information. I think I like the presentation, and I like the like to know of the possibility how to do this, use this kind of Wireshark tools, right, for this kind of use case. But Rick, I was thinking also kind of the information perhaps very tool specific or something could be we could use as a supporting document rather than informational, like because of the process, right? So we have the wiki and other things that we can put out this kind of information if we don't have to big long process of having informational document. But if we have a lot of things like this that we want to bundle together into some sort of document, information document, that could be a good thing. So this is an proposal, like these are options we have. We don't need to decide now, but
yeah, I would disagree with you, because yeah, I take your point that if this is how to do it in Wireshark, that's not appropriate. But I can see an informational document that describes a reliable way to detect the version of fragments of a TCP/CL conversation being useful for people implementing firewall filters, this kind of the standard traffic policing stuff, as well as tooling. Having the DTN working group states informationally that this is a preferred way of detecting a TCP/CL version from fragments. I see that as a generic document, but let's take that offline. But I take your point.
But then I agree with you. Then I agree with it. I was thinking like your comment was more towards this kind of tooling thing. But if we have this kind of information used for a lot of other things, and kind of like best practices that we were describing, so that's a very welcome document, I would say.
Mm-hmm. Okay, cool. Yeah. Thanks, Ed. Brian, I think you're up again. I think you were getting you out of the way at the beginning, so to speak.
Yes.
So if you want to go straight ahead.
I will. This next presentation also is pretty short. And it's really a restatement of some earlier work that was presented at an earlier IETF related to cozy security. The background is really the same here. I'll restate this just for anybody unfamiliar, that the BPSec default security context that, as Rick and Ed had mentioned, is going through the editor's queue now, is absolutely usable, and it does what it is supposed to be doing, but it is intentionally limited in scope. It has a small number of symmetric encryption and MAC algorithms. It defines some AAD to bind to a bundle and to a block, but it's missing things like explicit key identifiers. So doing something like key rotation becomes a challenging activity. And for internet-facing nodes, there really is a need for PKI integrated security, and this was something that the security area review of the BPSec came up with. And from their perspective, PKI is really important for internet-facing scalability. And the main thing is we don't want to have to reinvent the wheel. BPSec provides a great framework in which security information can be included in a bundle. And the COSI, the CBOR object signing encryption, already has a syntax, and it really fits well into the, I'll say, asynchronous, self-contained type of environment that bundles exist in. And it already provides a wealth of extension points for future security algorithms. So the idea here is that this is not proposing to alter anything that's already in BPSec. It is intended on handling symmetric key and PKI algorithms in a way that is already standard. All these things are already standardized and already exist out of the COSI working group. And an important thing here is that because this is embedding a COSI message proper, by using this, you get all of the benefits of whatever comes out of the future of the COSI working group. And that includes more optimized algorithms related to signatures. Potentially, they're working on post-quantum and other types of future algorithms. And the idea is to take that benefit when it comes down the line. And the other thing is that this is not just about the on-the-wire encoding, but this is also about library and tool support for COSI. There already are a number of libraries and a number of languages that handle COSI, and it's made to be small. It's made to be used in IoT type devices, so it's not done in a way that's burdensome to the system. A little bit about the proposed context, that there's one code point currently that would be allocated, and the same code point has the exact same semantics between BIB and BCB in that the security result is a COSI message. And then there are logics about in a BIB, the type of COSI message that should be present is either a MAC or a signature, and in a BCB, it should be an encryption message. And then there are some parameter types defined that use AAD scope exactly the same as the default security context. And this could be even simplified to say, just do what the default security context does. That's a potential edit. Deduplication is a big thing. COSI allows you to include a lot of details in each message, but presumably if I'm a security source, I'm going to be adding in multiple signatures. I want to sign several different blocks at the same time. And so this provides a mechanism to extract out duplicated COSI headers and just put them all in one place. And then the BPSec results is really where the COSI messages end up going into. And one of the things that you can get out of the box, off the shelf, in a sense, is all of these mechanisms for handling public keys, for handling X509 certificates. A lot of more complex activities can be already accommodated in this kind of messaging. And so the message tags that are already existing, that are already in use by libraries, is proposed to be used as result type codes, so it's not inventing new registries for these things. And the idea is that this document defines I'll show it on the next slide, I believe, but a minimal set of interoperability requirements, because COSI as itself is a framework for embedding security information. And the idea here is to say, I'm going to skip to it right now, that these are the minimum of how you do COSI when it's embedded in BPSec. So there's a set of symmetric algorithms, and then the main benefit of this context beyond the existing default security context is to be able to do things like the identified key wrap, to be able to use off-the-shelf elliptic curve, Edwards curve RSA signing today. There's ongoing work in the COSI working group to add other variations, other optimizations, but this is supposed to be the minimum of, if you want to do PKICs, that here's how you do it. And then last slide is just to say that this exists as a personal draft now. It should be pretty self-consistent, but this is just offering it up as a potential adoption to be able to get the benefit of PKI and PKICs in BPSec in a very short amount of time. And the proposal also is that this would be using the exact same certificate profile, the exact same mechanisms, all of the stuff that's already defined for TCP/CL for using this within TLS. It's saying you can keep all that, and now you can use it within a bundle. And there are still some open questions about technical details, but those, if it's adopted, could be worked out. And that's all I have for this.
Okay, Brian, thank you very much. And then just me in the queue with my chair hat off. I just wanted to say I love this work. When we were building BPSec and the concept of security context in the working group, it was clear that defining frameworks like this are sort of part and parcel of how contacts are likely going to work. And having something like this is far better than a BPv7 user saying, instead, I will just produce COSI encoded work as payload and then not have a good answer for that for individual extension blocks as well. So I think that your approach here is correct. I think that it's something that's needed, and hopefully that's something that we can get in and get the technical review on and work any additional technical things. But good work. Thank you.
Yeah, same. Rick here with my chair hat on. Yeah, Brian, this is good stuff, and I'm agreeing with everything Ed just said. So are you asking for working group adoption? Because as I read the new charter, hopefully official new charter, this is in scope. This is enhancements to BPSec. So my question is, do you want to adopt? Do you want to ask for adoption in this group, or do you want to ask for adoption in COSI? I think this group, but I'm interested in your answer.
Yes, so it is ready, I believe, for adoption. It would be a DTN document because it's registering things in the DTN IANA section and for the DTN purposes. And there would be, what there hasn't been yet and would be is I would invite members from COSI working group to look at this and say, does this look the way it ought to look?
So this chimes with the various IESG review about our charter about liaising with other working groups, and this is a classic example of where we need to go to COSI and say, double check this. And so if we working group adopt this prior to last call, we will get a review from experts in COSI to make sure we're doing it right as they understand it. So yeah, that makes sense. So we'll do a working group adoption call on the list, and as part of that adoption call, I will obviously be asking you for a date for when you think how long it'll take to turn around. But there we go. So thanks, Brian. I think that's all your slot. And next up, we have Scott, who is discussing what was originally called Big DTN, but is now called the scalability issues in Big DTNs. Hello, Scott. Do you want to present your own slides, or?
If you've got them, why don't you go ahead and present them?
Okay, no worries.
Give
me 2 seconds to do the share screen thing. Leave the queue. Can you see those?
I see it.
Excellent. Right, I will mute myself and just shout next when you want the next slide.
Okay. All right, then let's go ahead to the next slide. This presentation is really talking about a proof of concept that I think is a useful proof of concept to keep in the backs of our minds as we go forward with the updated charter. The motivation is for some time now we've been thinking that DTN really needs to find its way into commercial products in order to be viable on a large scale for example, the U.S. space program and the space exploration in general. And what I will hypothesize here is that the commercial products that we're looking for will be unlikely to emerge until there's potentially a large market for DTN products, and that in turn I think makes it necessary to demonstrate that it's possible for a DTN-based network to grow to an arbitrary size, which has not been done in the past. We do lots of demonstrations using small networks that instantiate particular routing or forwarding or reliability issues, but we haven't really demonstrated operation of a very large network that would make commercial product development attractive. So the intent here is to demonstrate that this sort of thing is possible, and to encourage the development of commercial products thereby. So next slide, please. So what is it about DTN that makes it difficult to make it large? And there isn't really anything intrinsic in bundle protocol or BTSec that limits the size of a DTN-based network. There is a second order problem, I think, which is that as we've experienced in deployment experiments and demonstrations over the past few years, you can readily configure DTN implementations to support a very wide range of communication scenarios, but that configurability, there's a lot of knobs, and so the deployment and management of DTN nodes is somewhat labor intensive, and that sort of inhibits anyone's ability to operate a very large network. Next slide. So the solution that is proposed in this presentation is that we can solve this by automating some of the routine tasks of managing the network in two ways in particular. First, the forwarding decisions, the management of forwarding decisions. How do you do that across a network comprising thousands or millions of nodes as opposed to forwarding nodes? And then second, and I think less challenging, is how do you automate the deployment of new nodes and do that in a scalable way? The two approaches discussed in this presentation are to address these two general kinds of problems. First of all, a concept of regions that I'll explain in a moment that decompose a large network into chunks of limited forwarding scope and therefore limited management challenge. And there's a mechanism for this tentatively called interregional forwarding that is presented here. Second is something that I've been sort of wishing for a long time, auto configuration mechanisms that makes it very straightforward to create a new DTN node without having to go through a large network management and configuration effort. And this DTN node auto configuration system is intended to demonstrate that that's possible. Next slide. So interregional forwarding, the reasoning behind this design is, first of all, assuming that delay-tolerant routing mechanisms really merge over time that enable the automation of forwarding among limited numbers of DTN nodes. And the contact graph routing that supports DTN that's currently running on the International Space Station is, I think, an existence proof of that, it is possible to develop these things and operate and deploy and operate them. So given that assumption, what we're doing here is defining the term region to be a set of nodes that is encompassed by a single routing regime powered by one of these mechanisms. And for example, the set of all nodes that are cited in any of the contacts of a contact plan, it would be a CGR based region. Regions, if you look at them a little bit sideways, look a little bit like autonomous systems. You could use them not only as domains within which forwarding is coherent, but also domains within which administration is located or security is standardized. Next slide. Okay, so given that concept, how do you forward from a node that is a member of one region to a node that's a member of another region without propagating enormous volumes of information across the network? And the interregional forwarding strategy discussed here is to use the first bundle that's destined for a given remote node from a source node as a sort of probe that you don't really know necessarily what other region your destination node is in. So send out a probe bundle that essentially finds it. And there are positive and negative feedback messages from candidate forwarding points that propagate back to the source, so that once the feedback has been received back at the source node, subsequent bundles that are sent to that same destination node can go much more efficiently just through a single path. Next slide. This is all based on implementation, and the DNAC and IRF currently implemented and discussed here are only implemented for nodes that are identified by endpoint IDs in the IPN URI scheme, nodes that are identified by number rather than by string. The same principles, I think, are applicable for other EID schemes. I haven't tried to do anything with that at this point. And DNAC, the node auto configuration, is all based on things that are implemented only in the ION implementation of DTN. Again, this is something that could, I think, readily be, the concepts could readily be adapted to other implementations. The DNAC and IRF in this demonstration, in what I'm going to be talking about, are built on some underlying capabilities that have been prototyped in the ION implementation of DTN for some time now. One is automatic contact plan synchronization that aligns contacts across all the nodes in what turns out to be a region, all the nodes that are cited in that contact plan. That in turn is based on bundled multicast, which in turn is based on contact graph routing. And there's also a reliance on the delay tolerant key administration prototype that has been out for several years now, which in turn is based on structures called trusted collectives that are sort of the, I think of as a DTN equivalent to servers. And those again rely on bundled multicast. So next slide. Oh, right. This is an illustration, and these slides are an example of how you use these things, what the way they operate. It's not a hypothetical illustration. This is actually the test case for the development of this stuff that now works quite well. Next slide. So here we start off by creating node number 21 in the root region of the network, which is region 1. So here's the instantiation of node 21 in the usual intensively managed way, which we've been doing for a long time in the ION development world. Next slide. Once you've got node 21, well, you can run DNAC at node 21 to create node 22 automatically. And next slide, node 23, and next slide, node 24. So these are all now nodes that have been created quite easily from just starting one node in the root region 1. Next slide. The next step here is to create another region, which is region 11, and you create a region automatically and implicitly by transforming a node from what's called a terminal node that lives only in one region to a passageway node that resides concurrently in 2 regions, which means that there are contacts citing that node both in the contact plan for, in this case, region 1, and in the contact plan for region 11. So by making node 21 a passageway between these 2 regions, we basically create region 11. And next slide. We do the same thing to transform node 22, a passageway, to brand new region number 12. Next slide. We can then move nodes from one region to another. So region 11 now exists. We can move node 23 into region 11. We can move node 24 into region 12. In this case, what we do here for purposes of the illustrations, we add connectivity directly between 22 and 24, because originally when nodes 23, 24, 22 were created, they only had connectivity back to node 21. Here we're adding connectivity from 22 to 24, and that enables us, next slide, to send a file using bundle protocol from 23 to 24. Now 23 doesn't know where 24 is, doesn't know how to reach it, but it does know that 24 is not in region 11 where 23 resides, because 23, through contact plan synchronization, knows all the contacts within that region knows that 24 is not cited in any of those contacts. So 24 lives in some other region somewhere. And the way you send a bundle to a node in another region is that you send it to all of the passageways out of the region that you're in. In this case, that is just passageway 21. So the bundle goes to 21. 21 then says, oh, I don't know where 24 is either. I likewise can only send it to 24 by sending to all the passageways out of region 1. I'm not going to send it to myself. So the remaining passageway out of region 1 is 22. I send it to 22. Next slide. And 22 then has only the option of, because it also knows that 24 is not in region 1. It knows about the contact plan for region 12 and says it then can go ahead and forward the bundle from 22 to 24 within region 12 using the intra-regional forwarding mechanism, which in this case is contact graph routing. And as that happens, node 22 sends back an encouraging feedback message back to the node from the passageway from which it received the bundle originally, saying node 24 is reachable through me, and 21 then will, next slide, send forward that encouraging feedback back to 23. So the next time 23 wants to send something to 24, it knows no matter how many passageways there are out of region 11, I'm always going to send it to passageway 21 because that's how I get it to 24. Next slide. So, okay, now we, given this little framework, we use automatic node configuration, create a brand new node 25 that is native to region 11. It doesn't get moved into it. It's being created in region 11 by another node that is already in region 11, which is 21. Next slide. Likewise, we create node 26 in region 12. Next slide. And the parent of node 26 is node 24. We move 25 to be a passageway into yet another new region, 111. And we create region 111 by transforming 25 into a passageway between 11 and 111. Next slide. And now, because 25 resides in 111 as well as in 11, it can create a new node that is native to region 111, node 27. And now, next slide, we want to send a file from node 27 to node 26. Node 27 hasn't the faintest idea where node 26 is. It knows that there is a passageway out of its own region, which is 25, so it forwards the bundle to 25. Next slide. Again, that 25 knows that it doesn't make any sense to forward it back into 111, so it forwards it on to 21. 21 sends it to 22, 22 sends it to 24, 24 sends it to 26. And there is encouraging feedback again in this picture, but I've left it off of the ensuing pictures here because it gets to be just cluttered. And next slide. So now we make node 24 a passageway between 1 and 11. We move it back so that it's back in region 1, but it's also still in region 1, region 11. And we restore connectivity between 21 and 24, which had been broken when we moved it into 12. There's still no connectivity between 26 and 22, which means that when 26 wants to send a bundle back to 27, next slide, it has to send that bundle to, there are two passageways out of 12, the bundles, the nodes 22 and 24. In order to send it to 24, great, it just sends it. But in order to send it to 22, it has to send it through 24. So even though there are two passageways going out, only one of those will end up being the selected passageway because it's more direct, and that's sending it to 24, which sends it directly to 21, rather than sending it to 24 in order to get it to 22 to send it to 21. Next slide. So this sequence then just shows that happening. 24 sends it directly to 21. It gets to 25 and then to 27. Next slide. Okay, so now we remove 22, which was a passageway between 1 and 12. Now 22 is no longer a passageway. We remove it from region 12. And for this next part of the illustration, we add connectivity between 23 and 25 directly. So now there are two ways out of region 11, passageways 21 and 25. Once again, when we want to send a file from 23 to 22, 23 sees there are two possible ways out. It doesn't know where 22 is. It sends it to 21 and also to 25. Next slide. And now 25 sends back discouraging feedback saying, thanks for trying me, but no, 22 is not reachable through me. It is not in any of the regions that I'm in. It's not in 11, it's not in 111. 21 does not say that because it knows that 22 is in region 1. It forwards the bundle to 22, and it also would send encouraging feedback to 23. So the next time 23 sends to 22, it won't bother to send it to 25. It'll only send it to passageway 21. Next slide. This is just another illustration. Now that we've changed the topology, 24 can send to 25 directly. And then the last part of the illustration is multicast. So here we've got node 21 sending to multicast group 76, of which there are two members, 26 and 27. And it does that by sending a copy to 24 so that it can reach 26, and to 25 so that it can reach 27. Next slide. Yeah, that's the end of that. Okay, so here's a hypothetical use case. DNAC can instantiate a new node in about a second, but part of what goes on with DNAC is optionally, when DNAC operates, it creates the new node on the same machine as the parent node, and then it optionally migrates it to another machine. The transplanting the new node to a new destination machine can take a little time because we use SSH and SCP, for example. And so taking 15 seconds per node is a reasonable guess at the required time. And assuming that we can have up to 33 nodes in each region, all right, let's assume that we've got a list of 29,000 machines we want to include in our network. That would occupy 879 regions. The first region is populated after 8 minutes, 15 seconds per node, 32 more nodes. And each of the nodes in that region can be the passageway to one of that region's subregions. Next slide, which is the last slide. Each of those 32 subregions can then be fully populated by another 32 regions in each one after another 8 minutes. And so each of those 1,024 new nodes can be a passageway to another subregion. And so another 846 subregions can be fully populated after another 8 minutes. So in 24 minutes, you can automatically deploy a fully interconnected BTSec secure delay tolerant network of 29,000 nodes. And in this particular scenario, every node in the network would be no more than 5 forwarding hops from any other node. That's the end of the slides, and I see 2 people in the queue. So Rick, I guess, can you?
Thanks, Scott. Yeah. First off, I'm going to say thank you very much for that. That's really interesting. It was really interesting to see a presentation at this sort of scale to talk about all these outstanding issues that we've got. Now, with my chair hat on, I need to remind people that, of course, Scott has touched on some routing here. I actually have quite a long list of comments, which hopefully will cover some of the other things, because I'm aware we're a little bit short on time. This is a classic example of where work in this area has happened in other parts of the IETF, and there's a wealth of experience we can bring to bear from those other groups. And also another reason why we need to tackle some of the earlier building blocks before we get onto some of the later things. So with my personal opinion on, I'm just going to go through a couple of quick things. I love your concept of regions. I know you and I have talked about regions offline a number of times before. My question really is, you talk initially about regions as administrative areas or areas of common naming, or perhaps areas that are geographically consistent, consistent in space and time.
I would say, actually, I think the mandatory part is that forwarding has to be there has to be a consistent universal forwarding strategy within the region. Other elements of commonality may be folded in there as well, but the required thing is that the intra-regional forwarding has to be consistent.
Yeah, so I think what you have described is the difference between an interior gateway protocol and an exterior gateway protocol in IETF terms. So it's great. It's brilliant when it's convergent evolution. I like to say it's yet another example of why that model actually works. So I'm really pleased to see that. I'm interested to see how this works when you have differently named regions. So you're moving between endpoint ID encodings. So rather than everything's using IPN, you can say, well, everything's using some subschema of DTN, and something's using an ICN style naming, and something else is using an IPN. That would be really interesting. The auto placement really worries me, because I think you're conflating the deployment of a node, the configuration of the node, and its position within some sort of hierarchical routing regional thing. I think, yeah, really good problem to explore and to describe, but I think definitely need to look at what is the role of neighbor discovery, what is the role of some sort of management system. So how much can AMA come to play in here, and all that kind of stuff.
Yeah, not to talk about right now, but yeah,
not to talk about right now, but it's
a lot of discussion.
Yeah, how do I just make a node appear and join my network is just a huge problem statement. But yeah, I think in scope we need to kind of discuss this and tackle some of the points. The third thing is the opportunistic forwarding / routing, because a bit of this is routing. Putting aside the naming issue, which I'm really keen on, and we'll come back to when I have some spare cycles. The reinforcing feedback you describe, there's a protocol called AODV, which has come out of the MANE working group, which does exactly this. And so it opportunistically explores routes to nodes that a node doesn't know about, handles the loop avoidance, understands aging of the information, and all of that kind of stuff. I thoroughly recommend you go away and read it and talk to Charlie Perkins, who is very, very switched on in this area. My other last request is, it's a terminology thing. I love your word passageways, but I think we call them gateways in the IETF normally. And I think
I specifically wanted not to be in conflict with the existing use of the existing terms. So I'm happy to revise that, but I wanted to draw a clear
in which case
at this stage.
I'm really interested in the difference between a passageway and a gateway then. But we should probably take that offline, because I'm talking a lot and other people probably have problems.
I specifically wanted not to overload the term gateway.
Okay, fine. My final statement is you need to look at protocol independent multicast as well, because that is multicast tree building. There seems to be some real similarities here. That's not none of those comments are to say what you are doing is nothing but good. I just see parallels everywhere with more mature and existing technologies that we can that you can steal good ideas from, learn from, and perhaps do a bit of gap analysis to work out what's applicable and what's not. But that's enough from me. So I'll shut up. I think this is a massive Christmas mailing list conversation I see coming, which I look forward to.
Yeah.
Go ahead, Ed. Sorry.
No, I was just going to go in and say, in the interest of time, we should get on to the last two presentations.
Yes, absolutely.
And then just to say, all of this fits well within the charter discussion at the beginning, which is we're doing a lot of work that is rooted in the unique nature of our transport, but we should also look at the work that's going on elsewhere and fill the gaps, which I think is what both of you are saying. So we'll take it to the list.
Good idea. So next up, I'm flipping rapidly between agendas and so on. Who is next? Why, I can see the agenda. Next up, we've got Emery talking about the AMA and the next steps. So I shall approve Emery's screen access and stop sharing my own. Did that work? Excellent. Go ahead, Emery.
Hello, I don't know if y'all can hear me and see a screen. So I'll move forward.
See you.
All right, excellent. So I was going to talk about asynchronous management architecture. There's already a draft out there. We are trying to rework this. I admit now, maybe this is not the right name, but that is discussed, and we can talk about even through this conversation. Ideally, here is to talk about some of the comments back is what makes AMA or DTN network management unique, and what are some of our next steps as we go forward. So one of the first things kind of in our research to find out and help us understand why this may be unique is to better define, what are the use cases we're trying to solve this for. In particular, one of the things we found recently, straight from RFC 7228, the definition of a challenged network. And this is something y'all have been talking about, from my understanding, for some time. A challenged network in that DTN case is truly those that have the incredibly long latencies, and in fact latencies where you cannot even form an end-to-end path when a message will be sent and expected to be received at a later point in time when the transmitter is now no longer sending. So I think that is a very unique case for challenged networks. With that said, I think DTN also has the use case of also working with constrained networks, which is talked about quite a bit in RC 7228, the idea that those nodes and those networks might be limited in resources. But that is not always true, I think, for challenged networks. I think the big one here is that latency. Going to sort of what a lot of y'all have been doing in this working group there to address those challenged networks. Y'all been developing protocols. There's RFCs. I think 3 of them on this list here noted earlier are about to go through, and hopefully by the end of the year actually have an RFC tag on them. New protocols to address that. So y'all have recognized that the existing protocols don't meet the spec. Let's find new ways to address DTN management, such as bundling, such as bundle and bundle, or sort of convergence layers, new concepts, dare I say routing, but for pushing those contact plans to these devices. So kind of accepting that there have been new approaches to DTN in general, maybe there's a need for DTN network management. So the current draft document for AMA outlines some of the services that are needed for management of these challenged networks and some of the desirable properties. You can see those here. I want to call out a couple because obviously there's the simple things like configuration reporting and administration, but when you really get into some of the more advanced features like autonomous parameterized procedure calls, desirable properties, intelligent push of information, the ability to sort of tell a node when it needs to send information and how to trigger on that. That kind of speaks to the rules-based execution of events. You know that you aren't going to be able to talk to those nodes synchronously. You know that you may not talk to them for days over a time, but you want them to queue up messages, reporting messages. When does it queue those up? How does it queue those up? And then where does it send those to? So some of these are the very important features that are needed in a DTN network management that we don't think exist in some of the existing protocols. And I'm going to talk through a few of those next and see and trying to see what might be different between those. So these are some of the existing protocols. Maybe there's others out there. Happy to talk about those. a note, like for SNMP Yang Core Conf, which is in the work, same thing for kind of autonomic networking in the works. These are each great. They've got a lot of great features. In fact, some of the features I think we want to bring into a DTN network management solution. But as they're written today, as they're used today, at least I think they don't necessarily meet the needs for that challenge network. So talk through a few of them. SNMP, we've probably seen it, used it for many years. It's simple, right? That's in the name. So I think one of the pieces here is it is purely a data element model, the ability to pass very single configuration items or to report on single maybe failure events. It does not have any of that need for autonomy, does not have sort of rules-based execution. It is strictly just a data model for querying and receiving individual elements. One of the things that I did want to point out for SNMP here is the fact that they organized it from the start with a very nice hierarchy. They kind of described, okay, there are, sort of the standardized spec trees, and then they defined each one of those up under that very clear sort of this is a spec for OSPF or RIP or whatever it might be. And then you have your enterprise specs, which is for all of your vendors, your Cisco's, Junipers, and so forth. Because that's nicely organized, you can reference each of the items in this tree very easily, which is something that I think is needed for challenge network management, and that's some of the future work. The next one here, this is gaining popularity a lot in the recent, is Yang, and as well as the protocols netconf and restconf. Yang is a full-featured data model, has a lot of capabilities for defining very, very complex data structure for how you would either access information from a server or node that is being managed, as well as how you can configure those. One of the interesting pieces is Yang is purely a data model. So any of the autonomous behavior that you need to build into Yang is accomplished via the netconf or restconf protocols. Netconf itself is very synchronous, so you need to establish that session to a Yang server, tell it what you want to configure, tell it what you want to receive, and that session remains connected the entire time that you're trying to send and receive those commands. So I think that one immediately kind of falls off the table for a challenge network. RESTconf changes that a little bit, so it's RESTful. Is definitely designed to sort of send commands to update that data model on the remote server, or send commands and say I want to retrieve information. But it's still, at least as it's currently written, highly dependent on a secure sort of protocol, TLS. It is definitely and it's limited to the Yang model as well, right? So I mentioned Yang as being a data model. If you wanted any sort of back and forth or collect a large data set, you would have to request that large data set, which then the message on the wire or air is pretty verbose. So that's kind of speaking to netconf and restconf. There are updates or new protocols either existing or in the works, which are trying to remove some of that synchronous behavior. So this is some of the now kind of called out as asynchronous behavior of Yang. So you've got both subscription to Yang notifications and Yang push. Very nice, because you can subscribe to the data elements of the Yang module. But again, because it is only a data model, you are limited in what you can do. So you can subscribe to an element in the model, and you can say, send me updates, send a Yang push update when that model changes, or at a periodic interval. But as it's defined today, those are the only two options you have to configure for Yang. So that falls back to that, if you need sort of rules-based execution of events, such as maybe I've crossed a threshold, or an error condition happened, you would not necessarily be able to trigger a larger set of a report or sort of a state of what's happening. So kind of differentiates those. Last couple things to talk about here. So there is an entire working group. It's the constrained resources working group. They develop a protocol under that called Constrained Application Protocol. As you can see in the picture here, it sort of fits on top of the transport layer, can be used for applications or anything talking to these constrained devices. You're talking about like sort of embedded IoT, low process, low memory sort of devices. So the protocol was designed to be very concise, which is something that we kind of need in the challenge network. But kind of going further, how are they approaching network management? Well, they are developing, I think it's in the works right now, a new protocol called CoreConf, which is going to use that Yang library, use the CoAP protocol to then talk to devices and push, data updates to the model or retrieve elements from that model. So a few comments there. Again, you're bound to Yang. And because there's a lot of concern, I think, for hey, we're starting to expose management of devices over the network, they're trying really hard to push security features into the CoreConf protocol. I think that's not bad. It's great for the use case. I think for some of the challenge network use cases, especially when you look at how y'all are approaching transport by a BPSec, bundle security, which is an entire protocol to put security into the transport mechanisms, you might be limited to then have an extra layer of security if you were to try and use this. There's also the sort of Yang item identifiers, or SIDs. This is how they can concisely encode access to each of these data elements inside the protocol, which is a nice approach. But at least as I read it today, there's no hierarchy. There's no way to reference, kind of going back to that SNMP OID structure, there's no way to sort of reference these are RFC spec or vendor specs, and then sort of what is the way to get down to the particular data element without directly addressing them with possibly quite large IDs. So it makes it a little bit different. The last one I wanted to mention, I don't think anyone has talked about it much, but because we call out that autonomous behavior is a desirable property of challenge network management, I think it's fair to at least acknowledge some of the work that's going on in the ANIMA working group, as well as the network management research group, autonomic networking and intent-based networking. So what really differentiates those maybe from DTN management, these are, actually kind of goes back to the last presentation, the ability to drop a node in a network and have it self-configure, self-optimize, self-heal, and so forth. There's a lot of work to do that. What I understand is there's a need for very synchronous sort of communication and connectivity between these nodes. There's also a need for supporting infrastructure like DNS, like DHCP, that can help once you drop the node and it talks over that autonomous control plane. It knows how to then start to self-configure because it gets a little bit of information to talk to these particular services. So again, kind of going back to what is that challenge network use case, very different from this one as well. So I kind of mentioned all of these things. I think there's a lot that we can learn and borrow from these different protocols. But why I'm talking to you today is to say, do we think any of these are applicable to challenge networks? Have I missed anything? Have I misunderstood anything? And do we agree that there is sort of a unique need to challenged network management today? So I will pause. I see actually Rick in the queue. Speak up. Let me know.
First off, Emery, thank you. I think this is a really good gap analysis of what's out there in the IETF at the moment, which is particularly relevant as really that is what the ops area directors asked us to do. So if we can try and capture this information in the AMA document as well, then I think that will make that document great. My second point is I would really like to present the inverse of this, or you to present, or someone to present the inverse of this presentation to the NetMod community at the next IETF. So basically, instead of presenting to us to say this is what everyone else is doing and why it's difficult, present to them you have all of this and this is why it doesn't quite work for us, help us. I think that would be a great conversation opener with them. So that's kind of a request to you or someone you work with or know well to try and put that together, and we can take that offline. But otherwise, thank you. Really good. That's all I wanted to say.
Roger, no, I completely agree. I mean, working through this has been actually nice because it actually helps us understand, okay, what are those desirable properties? What makes it unique? And then we can talk about those more clearly. So I agree, and I'm happy to do that. My last comments here, right? So we are working on an updated AMA spec. We've started to include some of these differentiators in the one that was published right before IETF112. I think there is a little bit more work that's needed to really emphasize like the rule-based autonomy, clarify that need for hierarchical moderated absolute data definitions, really clarify that it's independent of the underlying transports. You look at all these other protocols and they say, well, it must use UDP or it must use TLS and so forth. I think that is something different for challenge network management, and try and make sense of this. So the last slide, next steps, right? Just like you said, continue to work with these other IETF working groups, discuss overlap, discuss what's good and bad from each, and then we start to look into the maybe more interesting things, right? What are those application data models, asynchronous management models, the protocol, and so forth. So I'm done. Any other questions?
No, this is Ed. I just wanted to come back and echo what Rick had said. This is an excellent sort of updated review of both what DTN needs for management and how it fits into sort of these emerging other ecosystems in the ops area. And getting a presentation, the inverse presentation of this over to them is absolutely something that we'll get on the books for the next work for the next IETF.
Awesome. Thanks all.
Thanks very much, Emery. So I think next up, I do need to find a way of getting the agenda on the same page as everything else I'm trying to do. We've got Sarah talking about another part of the management piece. Sarah, are you okay presenting your own slides, or do you want to shout next at me?
Yeah, I can present my own slides.
Okay, excellent. No worries. Go ahead.
Okay. I'm having some difficulty sharing. If you want to share, then that'd be okay.
If you go again, I had to click a button to accept again. So if you it was me, sorry. Is that?
No. I'm still getting an error.
Okay, no worries. I just closed the window typically. Give me 20 seconds just to go and oh, actually it's available inside here. They've provided there's asynchronous. Look at that. Right. Now I have to work out how to do the share.
Okay, thank you. Yes, so my name is Sarah Helbel, and I'm presenting the Asynchronous Network Management System, which is a project we have going on here at JHUAPL. Again, this is for the management of challenge networks. We are tracking the name change, and we'll make changes accordingly as we continue our work. Next slide. So as we all know, managing DTN networks is important. In the ANMS project, we are incorporating all of the work from the standards community into a tool to manage challenge networks. The tool we're developing is meant to show that we can build a console using DTN standards that both operators will understand and will like to adopt for missions. This tool will incorporate AMP and all the future changes to the specification, whereas we also plan to feed any required modifications, etc., that we discovered in our development of this tool back into this community for discussion. Next slide, please. So the goals of our system are listed on this slide. In short, we want to be able to monitor and control network nodes and challenge networks, interoperate with existing network management tools, and be able to manage implementations of bundle protocol agents. We're initially testing with ION integration since it ships with a reference NM agent, but we should be able to operate with any BP implementation once our development's complete. Next slide. So this one's getting a little bit into our implementation. This is a layer 1 decomposition of how we see ANMS fitting into a larger mission control system. So the blue stadium or pill shape in the middle is the ANMS tool and everything it encapsulates. We plan to provide services for data management, system administration, automation, orchestration, health monitoring, agent command and control, etc. And we see this interacting with agents on the network for BP, as well as interacting with other machines on the network for legacy protocols such as netconf and other protocols that we're envisioning. Human users of the system will be mission operators and network admins. We plan to provide default user interfaces for mission command and visualization of reports coming back from agents. Next slide. So this is getting a little bit more into how we are breaking up ANMS among different modules while we are developing it. The key point here is that we do want to build the system in a modular fashion in order to allow users to be able to plug their own solutions into ours to the maximum extent possible. So this slide shows a notional representation of our layer 3 architecture. So the central processing block there will be handling all of the automation and orchestration sort of activities. It has a local agent there running to do things like state-based rules, time-based rules for the local system. We have a data access layer for all of the data needed to orchestrate this system. The agent clearinghouse will handle everything coming in from agents. Application access is everything coming in from the user interface and things like that we build out. The transcoding piece there is a little bit interesting. So that one will handle translating between any different representations of commands to agents. So obviously right now we're focusing on like string encodings going to CBOR. But we do want to make that one pluggable as well so that you can plug in your own codecs for any sort of agent-specific encodings you need. Network access handles everything talking out to the network, and it's kind of small on this slide, but those three purple diamonds at the bottom right are the default visualization tools. So that would be the visualization of health and things on the network, as well as admin and agent command and control. Next slide, please. So along with the modular theme, we are building the system out to allow distributed deployment of system components. So in other words, the entire system could be deployed on a single machine as shown in the upper left, or it will be able to be deployed across a number of physical and virtual machines as shown in the bottom right. Our goal for this approach is to allow adoption independent of the organization's deployment strategy, whether it be local physical servers or cloud deployment, such as AWS or any cloud vendor. Next slide, please. So our project is set up in 5 spirals over the course of the next 2 years. We are currently in the first spiral of development and plan to make spiral releases open source as they are completed. For spiral 1, we're focusing on a single motivating use case to get everything just up and running. So at the end of this spiral, we'd like users to be able to configure ANA agents for report generation and receive reports back and display them in our visualization tool. To kickstart development, we're currently using existing ION agents, and a lot of our effort is actually focused on containerization of components for easy deploy and integration at this point. We expect our first release to come out in early 2022, and we're looking forward to interacting more with the community and receiving feedback at that time. And I think my last slide, next slide. So this is just to wrap up. Here's a depiction of our logical view of the different components that we're building out and the functionality in each. The yellow boxes are the ones that we envision working on during this first spiral. Everything will be built out as we progress, but that will be what the first cut looks like. I believe that is it. Any questions? I see somebody in the queue.
Go ahead, Alberto.
And Sarah, thanks for the presentation. It's a very, very interesting topic. You mentioned you you basically would like to have feedback. What specific areas you are looking feedback for?
So once we get the tool, once we get the first iteration of the tool out there, just usage, different things you'd like to see, whether or not the visualization works for you. I mean, even feedback on if you have any specific areas that we should focus on for our future spirals, like prioritized, then we could do that. But really, once our first increment is out there, user feedback.
Okay, thank you. I'll reach out offline.
Okay.
Good plan. Thank you very much, Sarah. I'm keeping an eye on the time, and we overrun in about 12 seconds. But thank you for that. So it should be open mic. If anyone has any last minute comments or questions, we'll try and keep the session going for a little bit longer. But otherwise, thank you very much for attending. For those who have to shoot off to another meeting or an emergency meal or something, I'll turn my video on. For some of you, it may be lunch or breakfast, but otherwise, thank you very much for all your contributions. Some very much on Charter, some very much looking into the future, and that's always nice, hopefully educational and interesting. I'm filling time while I wait for somebody to jump into the queue. Adam, do you have anything to add about the minutes? Do you need somebody to correct any information that you missed, or are we looking okay?
Please look through, make sure I didn't miss anything. I know that synchronous management updates, I got distracted here, so I'm going to go back and watch the YouTube video to get some more copious notes, but fill in where I've missed if you can.
Okay. Thank you very much. So as usual, the minutes will be coming out some days from now because we'll need to just recheck on the YouTube and just liaise between the chairs and Adam just to make sure we've got everything there. But otherwise, thank you very much to our presenters. Thank you very much to our attendees. We will be having a meeting at the next IETF. It may be possible to have in person. There's some discussion about whether it's in the EU or the US, COVID willing, etc., etc. Either way, we will be meeting virtually or in person. So I look forward to speaking to you before then. Meanwhile, please take discussions to the mailing list. There's lots of interesting things. We will be asking for the working group, I beg your pardon, we'll be asking for the working group adoption of the 2 documents that were requested. I'm just checking my notes. And that's probably it. Anything you want to add, Ed?
Yeah, just 2 things. As we start talking now about milestones associated with some of those work areas, please, if you want to work on those, we're going to put a call to the mailing list, but that doesn't mean in the interim you can't jump forward on the mailing list and say, I would like to work on this, and we could start proposing and having those milestone date discussions. And then lastly, just for Ronnie Bull in the chat, he did post a link to another project in the IPN SIG and some of the work they're doing for DTN and a report that's coming out, and we should also be cognizant of that additional work. So those are my 2 last items.
Okay. Yeah, I just thought one last thing. A couple of people have got personal drafts on topics which are on the new charter. If they want to just reissue them to sort of bring them back to life in the document tracker, that would be great. Even if you just change the name and resubmit, it will keep it alive rather than it disappearing into the limbo of expired personal drafts. But otherwise, thank you very much for your attendance, and we'll speak to you next time in person or virtual or whatever. Thanks very much. I don't know how to close the session. I'm just going to quit the room and turn my camera off. Thanks, guys. See you later.
Good seeing everybody.
Bueno, sabemos que la compu era un rival muy difícil, muy bien posicionada en el campo, con una muy buena defensa. Hemos empezado muy bien el partido, con unos penaltis a favor, unos cuantos. y un gol tempranero, pero después se nos ha complicado. Hemos tenido capacidad de área. Ellos, a través de un penalti,